Combine Harvester in Newton, Kansas is a new grain harvester manufacturer. We took the typical concept of a combine that many years ago, prior to World War II, combined the cutting and threshing into a single machine and added the third component, hence tri-bind, by adding a 1,000 bushel grain cart. A couple of challenges we faced in our new design. One was the control of the concaves around the rotor, and the second one was the opening and closing of the grain bin extensions required for our 1,000 bushel capacity. The needs for the grain bin extensions became somewhat broad because we have two very large flaps, if you will, or doors that we have to open and close. We also have another element in the middle, which is the auger that brings the grain up into the grain bin. That is a folding auger.
The heart of the combine is the rotor. That's where all the threshing takes place. And outside of the rotor is the concaves. And the concaves need to be in a certain location. And that location varies crop to crop. It could be set close, it could be set wide. And you need to be able to control that and know where they are, depending on your crop conditions. We started out with a one actuator system that had a linkage in it that operated 3 cranks, and it wasn't capable of physically doing the work. The actuator was plenty strong, but we needed to be able to control all 3 cranks at the same time. We needed an actuator that we could get a signal from that would be repeatable and use that to determine how far our concaves were from the rotor.
We have considered using hydraulic as well as a standard H-bridge type actuators, which has been an industry standard for a number of years. One of the things that is experienced with the hydraulic units using hydraulic cylinders is you always have internal leaks. Therefore, it's very difficult to lock things into place. Using an H-bridge type actuator, now you require a high current type controller to be able to switch them, or using external relays to switch to be able to change directions. But they typically use a different device than also for feedback. So now I have to provide a signal to control it, but also I have to monitor a separate signal for the analog signals coming back. So in 2015, when we started our design process, we focused on using an electric actuator for the concave as well as the grain bin extensions. It was shortly thereafter, which about March timeframe, when Thomson released the HD actuators. And being a device that is on the CAN bus, our machine network bus, it lent itself just very easy to implement it within our system with built-in feedback as well as built-in control. Basically, we provided a single point and it drives to that point. There are 5 actuators in the grain bin extension system. 2 are used on each side, 1 on the folding auger. We have to coordinate on one side for unfolding the door. They have to stay within 5 millimeters to keep from bending and causing damage to that door. The 2 sides have to work together so we don't have them crash into each other. The 5th actuator that is part of the coordination is on the bin fill auger, so it has to unfold after the extensions are up, and then it has to go down before the extensions go down.
With the concaves, we've got 3 actuators. 2 are extending while 1 is retracting. One time we tried a hydraulic solution. It was a installation nightmare. It was not easy to install, set, and maintain. It would drift. We would have to bleed the hydraulics out, and the HD actuators, it's a lot cleaner installation. It's a lot easier. We can set it up and we're done. I know it takes a lot of force to turn these cams to adjust the concaves, and the HD actuators, they're doing the job for us. They're providing enough power for us to make those small, slight adjustments and lock it down and keep where we tell it to stay. What I appreciate about the HD actuators is it provides the force I need. It has a replaceable wiring harness. It communicates with our CAN bus, and you can set it and forget it. Put it in place, and it's where you want it to be when you want it to be there.
So with the HD actuators, they require 4 wires, 2 wires for the CAN communications and 2 wires for power. The advantage of that over a traditional H-bridge is we don't have to have a device, relays, or a controller that is switching power to drive the motor either direction, and we also don't have to provide some mechanism for decoding the analog feedback on the unit. With the HD being CAN bus, all that is presented as a message that is read or driven by the controller. Some of the other things that the HD also presents is I can monitor exactly how much current it's using. I can determine a fault state. So just by reading a simple CAN message, I know if one of them has failed, which I can use to either not allow damage to occur to the system and also be able to report that back to the operator, where with the traditional H-bridge, that's much more difficult to achieve. So with the concaves, the implementation on the CAM system, we're required to have two extending while the third is retracting, or vice versa if we're going the other direction. Because of them being on the CAN bus, that is easily achieved because the way they are internally providing feedback for their position. Trying to do that with an H-bridge and stop motion and change direction would have been a lot more through hardware than software, and a lot more difficult. With an HD unit over the network bus, all the information, power is provided to the unit, a position is given for it to drive to, and that feedback is available instantaneously off the actuator.